Good afternoon, 8th graders. This is your video on polygons. There'll be page 53 in your notes. You'll have a front blank side, and then on the back at the top there's going to be a chart, and we'll get to the chart later. So make sure that you don't write too big and you have enough space to put all that we're about to do on the front page. Go ahead and make this chart. Make sure the title's polygon name, and on the right, the title of that column is number of sides. If you want to put a hashtag for number, that might be a good way to abbreviate. So pretty much what we're saying in this table is what is the name of the polygon that has this many sides. So a polygon that has 3 sides is triangle. Should be familiar to you. And the prefix, the first part of the word, typically is what tells us. So triangle, the tri means the 3. For 4, the abbreviation is quad. So quad, and then you finish it with relateral, quadrilateral. 5 is going to be pentagon, like in Washington, the Pentagon building. 6 is going to be hexagon. Good way to remember that is the X. So 6 and hexagon. That N is ugly. Okay. 7 is the one that people usually forget. It's heptagon. And there's not really a trick for that. You just kind of need to memorize it. 8, octagon. So like an octopus. So I can't remember. That might be an A. Octagon. I think it is. Yeah. Okay. 9 is non-agon. It's an O. Non-agon. So 9, non. 10 is decagon. So dec would be like decade. Yeah, decade. And then 12 is pretty much, oh God, I wrote decade. Okay, so not decade, decagon. Okay. 12 is just like decagon, but you add the word do before it. So do, decagon. And you can think about this as being like, you can think about this as being, oh gosh, I can't write today. Do, decagon. So the decagon is like the 10, and the do is like we added on 2. So 2 decagons. So 2 plus 10, 12. All right, now moving on. Something that we need to think about is, first off, a triangle's angles add up to 180 degrees. So that's something that you probably know at this point, but maybe not. So 180 degrees. So if one of them's 20 and the other one's 100, that means the third one is going to be whatever it takes us to get to 180, which would be, I think, 60, right? 20, 100, and 60. Okay. So looking at like a quadrilateral, and I think this is a pentagon, there's 5 sides. We could also figure out how many angles, how many degrees all these angles add up to by thinking how many triangles can I make out of this polygon. And the way that works is if you start from any of the vertices, the points, if you draw a line like this, look, how many triangles are there? 1, 2. So that means it's 180 degrees times 2. So there's 360 degrees in any quadrilateral because there's 2 triangles in there. Now let's try the pentagon. So starting from here, we can make 1 triangle there. We have to always start from the same vertex. There's another one. And it looks like I can make 1 more. So this was a hexagon, actually. 1, 2, 3, 4, 5, 6. Yeah. Okay, so how many triangles are there? 1, 2, 3, 4. So it's 180 times 4, which ends up being 720 degrees. So that means all of these angles in this hexagon add up to 180 degrees. Another way you can do this is just by using a formula. So this is the formula here, 180 n minus 2. N means how many sides are there. So for instance, up here, our n was 4 because it was a quadrilateral. We did that, 180 times 2, we get the same thing, 360. If we do the same thing with 6, so it's 180 times 6 minus 2. 180 times 4, which is also what it was up top, up here. Oh, well, let me drag it. Yeah, 180 times 4 minus 720, or 180 times 4. equals 720 in degrees. Okay, now the next thing we're going to talk about is a regular polygon. So a regular polygon means that all the sides and all the angles have the same measures. They're equal. So looking down here, which of these appear to be a regular polygon? So we're going to circle those. So try your best to draw these. This one here, this is a hexagon, appears to be a regular polygon. So we would call this a regular hexagon. This guy, which I think is also a hexagon, you can tell like this side here is not the same as like this side here, right? This one's longer, so that's not a regular hexagon. This pentagon, it appears that all the sides are the same and the angles, so we would say it is a regular pentagon. And this quadrilateral, looks like this bottom side is too short, so that is not going to be a regular quadrilateral. Okay, next thing. So to go and turn over on the back. Inside the family of quadrilaterals, we can get a lot more specific. So, for instance, there's two main categories of quadrilaterals. The first one you should remember is called a parallelogram. Both sides, both pairs of sides are parallel. So like this side and this side, if they were to continue on forever, would never touch each other. And so the same is true for this side and this side. So that's a parallelogram. You would also say this is a quadrilateral. Any of the ones up here on the top, these three. Now another type that's not a parallelogram, that's a little more special than just a quadrilateral, is called a trapezoid. A trapezoid will have just one pair of parallel sides. So like this pair is parallel, never would touch. However, this pair here, if they were to keep going on, they would cross. And the same thing is true for this other one. So that's the two big types of quadrilaterals. And same thing, this trapezoid, you would also be able to say it's a quadrilateral. So it would have like two names. Inside of parallelograms, it gets even more special. So kind of over here, which look kind of familiar, is a rectangle. So all the angles are 90 degrees. They're right angles. You could also say that a rectangle is a parallelogram and a quadrilateral. Then over here on the right, a little more special is that all the sides are equal. So it's a parallelogram, but all these sides have the same measures. That's called a rhombus. Now if you notice, these angles here are not going to be 90 degrees. See, that's definitely smaller there, the one that's a lot more like a diamond, and the ones on the sides are bigger. So it doesn't have 90-degree angles if it's a rhombus. Rhombus, parallelogram, and quadrilateral. Now, when these two ideas meet, when we have all equal sides and all right angles, we get what's called a square. Now, the square, you would say it has like 5 different names. So it would be a square. You could also call it a rectangle because it has those 4 right angles. You could also call it a rhombus because all the sides are equal, and a parallelogram and a quadrilateral. So you would write 5 names if you saw a square. And that's what we're going to do next. So we're going to do 2 of these together, and then you're going to do the last one. Okay, so I'm looking at this figure. It is a quadrilateral because it's got 4 sides. So we're going to write quad, I'll abbreviate. And then it's also a trapezoid. Now, there's really nothing else it can be because all the other names are inside of parallelograms. So once we do quadrilateral and trapezoid, that's really it. Now this one, looking at it, it's also quadrilateral. There's 4 sides. And it is a parallelogram. And then it's a little more special because these dashes, they're all 2 dashes, means that they all have equal sides. And a parallelogram that has all equal sides, but it doesn't have 90-degree angles. That's right here. It's called a rhombus. So it's got these 3 names. And we would stop there. So we've got these 2 here. Make sure you drew the shapes as best you could. And then you're going to draw this last one, and this is what you're doing for your homework. I want you to tell me all the names that apply for this figure. So it won't just have one name. It won't even have just 2 names. So that's what you're supposed to do. All right. See you later.